Hello everyone, welcome back. So in this video we are going to understand this LeetCode problem number 3091, where it is saying check if there is a valid path in a grid. So what we have given is you are given an m cross n grid, and each cell of the grid represents a state. Means the state of grid ij can be any of this number 1 2 3 4 5. So when 1 is there, right, so it is a state. It means like a state connecting left cell and right cell, and so on we have given for each numbers. As you can see, let's suppose for state 1 it look like this, for state 2 it will look like this. Means these are the connecting paths we have given for each number 1 2 3 4 5 6. Okay, now it is saying you will initially start the state of upper cell. Means when you will start from here, so this is a 0 0 cells upper left, and you have to reach to the bottom right, means this part m minus 1 n minus 1. Okay, so a valid path in the grid is a path that starts from the upper cell, right, upper left cell 0 0, and ends at m minus 1 minus 1. The path should follow the states that we have given, and we have to notice also that you are not allowed to change any state. Okay, we have to return true if there is a path in the grid, or will return false otherwise cases. Okay, now coming back to the constraint, this is what we have given the constraint. Okay, so let's understand the very first one, right? So what we have given, when one is given, means we have to go to left, and the right we have to go. Okay, but here if you see, we start with the 2, right? 2 means we have to go up down, so from up we have to go to down, up down. If you see, we'll start from 0 0, so the first path is happening is 0, is from up and down. So let me tell you how. Okay, so as you can see here, right, we found the very first cell here is having the state 1, so value is 2. Means when we have 2, it means it's a type of 2 where we have to go from up to down. Means from up we have to go to down. That is why we are seeing we are going from up to down. Okay, then we have 4, right? So what is the meaning of 4? 4 means we have to go to the right and the down, right? So we'll start with the right and going to the down, correct? So in this case, it will become what? This path, right? Next we have 3. 3 means we have to go to the left, and then we have to go to down, right? And left down. So it start from the left, right, going to the down, right? So we have to connect all these paths that we have given, right? Like 6 5 2, right? And once you will see that there is a path, and finally when we'll come to 2, right? So 2 will come from right to up, so right to up will come, and all these will match, and it will reach to the last cell. So this is the first cell, and this is the last cell, you can say that. So it is saying, as you can start the cell at 0 0, you have to visit all the cells of the grid, and you have to reach to m minus 1 n minus 1. Means if this is 0 0, this is your n minus 1 and m minus 1, or n minus 1 n minus 1. You can switch it. Okay, so that is what we have given, right? Because this is what it is saying, if there is a path is there that we can reach, means this is we have to return as a true, and that we are saying that. Okay, let me clean it. The very first thing we should understand, that when we are moving, right, when we are moving from, let's suppose, A to B, Okay, when we are moving from A to B, then we'll say from A to B is valid or not. So if is valid means moving from A to B is valid only if the very first thing we can say A allowed, A is allowed, or we can say A is allowed, right? Let me remove this part, not get confused. So A allows movement towards B, and similarly B allowed movement back towards A. If these two condition is there, right, means A is allowed movement from B and towards B, and B allowed movement back to A. If this concept is there, right, if A is allowed movement towards B and B is back to A, towards A, then we'll say two-way validation problem. Two-way validation problem. So this type of problem is called two-way validation problem, guys, right? So we have to think like this. Okay, so what we have understood till now, that we have given, let's suppose, a grid, right, where each cell has a street that we have given, right? Each cell, there is two cell we have given, one cell is here and one cell is here, but each cell contains what? Street. So we have 3 street here and 3 street here, right? And these streets are given from 1 to 6 range, means it has a meaning, right, that we can discuss later. So each street connects a specific direction, like this it is connecting, right? So it is connecting like that. So what is our job? Our job is to check you can travel from this and you have to reach to this, means this is your 0 0 and this is your last m-1 and n-1, we can say that, right? This cell. So from here to here you have to reach, and is there path is there or not, that we have to check. But you can only move if the street connect properly. If it means we can only move if the street connect. Let's suppose it is coming from here to here to down, right? And at the same time this also connect, like it is saying up to down, then it will connect from here to here. If it will not connect, it will, let's suppose this cell will come here, right? So it will not connect, right? So that we have to also check. We also told that each cell contains streets, and streets is from 1 to 6. When we talk about the 1, it means we have to go to left to right. When we have 2, we have to go up and down, like that we have given. Let me write here. So when 1 is given, means we have to go left and the right, right? So left means like this we have to go. This is your left, this is right. When we have given 2 means we have given, means we have to go up and down, means like this you have to go. Then we have 3 means left and down, means you have to go, start from the left, right, but you have to go to down, like this you have to go. Okay, when we have 4 means 4 means right and down, means this is right and this is right and this is down, right? Means like this we are going like this, correct? And when 5, so left and up, means you have to go like this. Okay, then we have is 6, means we have right and up, means we have to go like this. So these are the connecting things we have. Once you will use these streets, you can connect to each other, because we have to check we can travel from this 0 0 to the bottom right corner m-1 n-1, but we can only move if the streets connects properly using these things that we have given at each cells. Okay, now we have also understood that we can only move from a cell A to cell B only if A is allowed the movement towards B and B is allowed movement back towards A, like this. Let's suppose it means it's a two-way validation problem. If this validation works, then we can say the moving from A to B is allowed, right? So let's go through the we can say example that we can understand. Let's go with this example itself. So we have seen this example, right, and how this will works. So let's think that we'll start with the DFS or BFS. You can use any of these, you can use. Okay, so when we'll start, obviously we'll start from 0 0, right? So at the very first step, right, what we have the value. So cell contains is 2, CELL. Okay, cell contains is 2 means we have to go up and down, right? So if you see, we are going up to down, and this is correct one, right? Because can only we have to go to down like these directions? Yes. Then we have to move to 1 0, correct? Because from 0 0 you will move to this position, but keep it here. Okay, but keep it here because in the last you will see that we have to connect, right? So in step 2 you will say, okay, what is the cell value? You will say cell value is, let's suppose call 6 we have. Okay, because if you see we have 2 4 3, then we have 6 5 2. Okay, so cell value we will take is 6 here, because if you see 6, it means we will go to the right and the up, right? So if you see, we are going right and then we are going up, correct? Then we came up from up, right? And we'll say, okay, if we are coming from up, what does it mean? So for this, you don't think much because we have to move here this position, but we have to check from up to down. So this is your two value. Let's suppose for this state is 2, this state is 6. I'm not talking about this one right now. Okay, so when it is 6, so we'll say, okay, the cell value is 6 and it is coming from here to here, right? Means as you see, right and up means it can travel. So we came from the up, we can say that, and that is a valid because we are coming from up, because previous is coming from up to down and this is come up to this side, what you call right, right, because up to right, right? And that is why this will work. Okay, now we'll move to 1 1 at this position. Okay, so this position will check, okay, what is the cell value is there? We'll check cell value is, we have is 5. Okay, so this time we'll say, okay, it came from where? When 5 is there means left and up. So we'll say, okay, came from the left, it is coming from the left, right? It is going to the up. Okay, it is going to the up, so this will work, right? Can we go up? So we have to check this one, right? Because we have to move to 0 1. Okay, so we'll say, okay, move to the 0 1. So when you will move to 0 1, because very first you start with the 0 0, then 1 0, then 1 1, then 0 1, right? When you reach to the 0 1, we'll say that, okay, let's check the value what we have here. So now finally we'll reach to this position, guys. Okay, this is 0 1. So when we'll move to the 0 1, we'll say, okay, what is the cell value is there? Cell value is 4. We'll say, okay, right and down means we have to come to right and then we have to go to down, right? So we'll say, okay, now move to no, for this one we'll say, okay, what is the value here, right? We'll check that and it is coming right down, means that is also valid, right? Next we will check is, now we have moved to this 0 2.
Okay, so we'll check this one, this value. It is the cell value is 3 and it means left and down, correct? When left and down, so it is coming left to down. This is also correct. Can we go down? We'll go down. Now finally we'll check the last value is 2. It is coming up to down, means this also connects. So from here to here we will connect like this and we'll say okay, yes, it's valid. Now that we reach to the destination, right? So guys, this is not just a traversal problem, it's a graph traversal with the constants, right? So each cell has limited directions, so it should must match with the neighbors allowed directions, right? So you have to think like, can I go there and can it accept me? Like we can go there or not, that is the fine thing, but it should accept the connection from here to here. So that we have to also check, right? So in this case we should use DFS or BFS, you can say, any of this you can use. And basically we have to keep two things in our mind. The first thing is the direction map. We have to use the direction map, we can say. And another we have to use is visited matrix. Two things we have to keep in mind, and then we can implement it. Okay, the very first thing, let's suppose about the how we will calculate the how we'll write the direction map. It's very easy. What you need to do is you will just use int and you will say 3D you will take and you will say that this is our directions. Okay, and the very first you will use, this is dummy direction, we can say. Okay, then we can use for, let's call 0 and -1, then we can use 0 and 1. This is for 1, direction 1, because we are coming from where, up to down, right? Similarly we'll go with another one, let's call, we'll go -1 and 0, or we can go 1 or 0 at both position, right? We can say 2 means up and down, right? We'll say okay, we'll use 2. This is from left to right, left, and we are going to right. 0 -1, 0 1. Similarly you will write for all other nodes and you will say, I'll show you, right? And then we can write, let me go to the code, then you will understand. As you can see, we have this is, I told you this is for the dummy directions, right? But rest of it from for direction 1, direction 2, direction 3, direction 1, each street contains some value, right? So each street is containing the value, so we have to define this, right? Or you can say, when type 1 is here, when type 2 is here, when type 3 is there, type 4, type 5 and type 6. Like this we have kept all the directions, we can say that, right? And once we will find the direction map, what we need to do now is we'll take a visited matrix of 2D and we'll keep it here. Okay, then we know that for BFS what we need to do is we'll create a queue, and on the queue we'll add a very first cell, that is 0 0, and we'll mark this visited map and we'll say that this is a true. Now what you need to do is you will check in the while loop, if queue is not empty you will poll that and you will say okay, what is at right and what is the row and the column you basically will want to find, right? At row and column you will check the row, if it is reached the last one means we found the destination and will return true. In otherwise cases what we need to do is we will find the through the direction map will pass direction, grid R and C will pass, so you will get the directions. So you just need to do R plus the direction that we found, right? That we will add, and you will get the next direction, next row and next column for the directions. So you will check the boundary conditions. If it is the case, you will continue, means you will skip that, and otherwise you will check the reverse connection. So how will you check the reverse connection? You will use the same what is the next row and column we have, and can we do the backward towards the A? Let's suppose if this is from A to B, right? So can we do the B to A, right? Means two-way validations we have to do, right? At that time we'll check that, okay, what is the next row? Can we do the back at 0? Can we find the row? Is it the row thing? If yes, we will add this again, next column plus the back. What is the back one? Can we find the new one? Like that we will check the condition. If it is matching, means we can connect it, means we'll mark this as a visited, and next row is also visited, next column is also visited, and we'll mark this as a visited. Then we'll go to the offer and we'll put onto the queue, next row and column, and if this doesn't meets, we'll return false. Means when we'll return the false, when we will not come here. So if there is a path and we have already connected the approach that we are doing, the graph traversal with the some constant that we will do, and we are doing the, let's suppose, BFS case. So if it is connecting all of, it will check all its neighbors, and if it is able to mark all of them and is reaching to the last columns, then it will not return the false, otherwise it will return false. This is what I have in this video, guys. So for the complexity purpose, we know that what we will find here. Let me zoom out so you will understand. So as you can see here, right, we are using a while loop. Inside the while loop we have a for loop, right? So just we can say that for the BFS we will use a number of columns we have, number of row we have. So m cross n is the O of m cross n is a time complexity, and for the space we are storing these two things. So this is just a constant, but we are also marking the visited. So we'll show O of m cross n. So that's what we have in this video. Do not try the DFS because it's a risk of stack overflow. So use BFS, that will help you to not go to the stack overflow. Okay, if you will try the union find, that will be a very good solution because it's a connectivity problem, but it's harder to implement here due to the direction constraint, guys. Okay, so that is why we should not use it. Otherwise BFS is the best approach, and you cannot try without graph thinking, and because there is many logics are there, so it will be to avoid that without using the graph. So common people do some mistakes. They check one direction for getting to reverse validations, and they do not mark visited one and trying to do greedy movement. So do not try the greedy approach also. That's all I have in this video, guys, and I'll put this code into the comment box. You can get from there. Thank you so much, and I'll see you in the next one.